Okay, so good morning once again. This is Kanga this morning. Today I'm going to take you through how we can discuss this land survey questions. So this is the questions and this is the data given. So this is the data given and these are the questions. So we're going to discuss how we can go about these questions. So please, if you have not subscribed to my channel, please do so. The name of the channel is Kanga Academic Tutors. So please, you can search on YouTube and subscribe to the channel. So let's start with the first question. Okay, so the first question says the distance of the line BE of the traverse at table 3 will be. So it's asking you to find the distance between the line BE. So using table 3. So let's look inside the data. So you can see table 3 here. So this is table 3. And there's the line. So we have B here, have the E here. Okay. So by calculating the distance, you're going to use the formula square root of change in eastings all squared and change in northings all squared. So that's the formula you're going to use. So let's look at table 3. So we can see that the first one, you're having a coordinate of point A, that is 99 and 63, that's for point A. For the point B, you're having the coordinate here. Point C, you're having a coordinate here. Point D, you have the coordinate here. Point E, you have the coordinate here. So these are the coordinates of the various points. So since we have been asked to find the distance between point B and E, meaning you're going to use the coordinate of point B and E. So now you will just take the coordinate of point B, coordinate of point E. So these are the eastern coordinates for the point and the northern coordinate for the point. So what we will just do is just write a formula, square root of change in eastings all squared, then changing plus changing northerns all squared. So I'll take my last eastings, that is 80. So it will be 80. So square root of 80 minus 82 all squared plus 63 minus 18 all squared. So the square root of that will give you the distance between line B to A. So that's the square root of that. So that will be the answer for, or the solution for question 1. And question 2 says, with reference to the tachometric survey data in table 2, the horizontal distance of H will be. So look at table 2. So now we can see here the formula is being provided to you. The formula is being provided to you. So you have the H equals to the constant K, then S cos square theta plus the constant C cos theta. So this is the formula for calculating for the horizontal distance. And this one can also be termed as the slope distance. So if you are asked to find the slope distance, you can use the H2, because this formula is used for the inclination calculations, or distance of inclination. So sometimes you'll be asked to find the slope distance, sometimes you'll be asked to find the horizontal distance. So it depends. So if the data given provides you with the angle. You have to keep in mind that you're going to use the inclination horizontal distance calculations. Okay. And you also have another formula for calculating for the actual horizontal distance. By this one, you can see the formula given. So sometimes you have to check in the data, the information given, they use that one to calculate for your or use for your solutions, calculate for your answer. So now with reference to question 2, the horizontal distance here, h, you can see h here. So the k here is the constant given to you, meaning that the length they are using for this, or they used for this leveling, is the analytical length. But for that one, it has a constant um, index of 100. Then we have the constant here. That is the multiplicative constant of 0.3. That's for the C. So you just substitute your values, then you get your answer. Now the small s here is the intercept, or the difference between the upper stadia and the lower stadia. So we just look inside the data here. So we have the lower stadia, you have the upper stadia. So just take the upper stadia value, we take the lower stadia value, and you find the difference. So the difference between the upper stadia and the lower stadia will be your S. And the K value here is provided to be what? 100. And the C value here is provided to be what? 0.3. So you just put that one inside the what? The solution. And they've given the vertical angle, that's the theta. That is 20.32 degrees. So just substitute all these values here, then it will help you to get your horizontal distance h, and that will be for the question 2. Okay, and let's move on to question 3. It says if the traverse at table 3 was observed in November 2007 and the magnetic declination at that time was 3 degrees east, varying at 0.5 degrees per year westwards, then the magnetic bearing of line BC at November 2018 will be. So now you can see here that we're talking about two magnetic bearings here. So meaning that one was given at 2007. So that one was the 334.80. Meaning that this bearing was given, or this magnetic bearing was given in November 2007. So now you have to understand. So if you don't understand anything, you can watch through. So for question 3, let's look at this diagram. So you can see here, we have the north here, you have the east here, you have the west here. So for bearing calculations, whenever the years are given, the years increase towards the north. That's what you have to note. The years increase towards the north. So you can see that this one is the 2007. So as we move closer to the north, it's increasing. So the 2018 will be closer to the north more than the 2017. So now you can just convert the, so you see we're using the table. We're using the table, table 3. So we're using table 3. So you can see line BC, this is the bearing for line BC. So you can just convert this one into a quadrantal bearings, and this is what you get. So it will fall within this quadrant. So you can just subtract the 334.8 from the 360, then this is what you get 52. So it will be not 52, not 52.2 west. That will be the quadrantal bearing for this side. So that will be the magnetic bearing from the line, or from the line BC to the year 2007. So now we want to find the magnetic what bearing for 2018, meaning that if we are able to get the magnetic declination for this place, we can either subtract or add it to the magnetic bearing here, and that will give us the magnetic bearing for this place. So now we just need the magnetic declination for this one. So now, according to the question, there was a variation of 0.5 per year westerns from 2007 to 2018, meaning that from 2007 to 2008 we have 11 years. The 11 times 0.5 will give us 5.5, and since the variation is to the westerns, it will be negative. So that is the variation or the magnetic declination, between 2017 and 2018. So this is minus 5.5. Now, the magnetic declination from 2007 has been given the question is 3 what degrees. So meaning that 5.5 plus 3 degrees will give us minus 2.5. So you can, so minus 2.5 being added to the 25.2 will give you this one. So this one will be the new magnetic bearing for the year 2018. So that's how you go about the question. So now let's go to question 4. Question 4 says that with respect to the leveling data in table 4, the height difference between point A and K will be, so table A and 4 will be, so you can see table 4. Okay, so this is table 4, and they said we should find the height difference between point A and K. So where is point A? So you have point A here, you have point K here. So now you have to note something here. Now we have the benchmark. The benchmark can be on a concrete pillar. It can be on a nail behind a light pole, or it can be any point at a higher surface. That's not the actual ground. That won't be on the actual ground. So you find the difference between the height. Make sure that you use the reduced levels. So you have to use the reduced levels of that particular change. So you have to use the reduced levels. So therefore, you have to look at the reduced levels at the terrain. Because the first one here is the reduced levels on the terrain, and the levels here are the reduced level after the finished design is out, or after the designer has designed the road or any level you want to obtain. So this one is for the normal terrain or normal land surface elevations, and this one is the terrain elevations. Okay, so what you do is that you have to take the first one. So this is the use level on the surface here. So, and this one is these levels here on the surface. So you take K and A. So the difference between the use level at A here and the one here will give you the height difference between the various points. Okay, then let's go to number 5. Based on the leveling data in table 4, the slope or the gradient of the line from point C to point H will be. So now the gradient, we're talking about the slope. And we know that from SHS, the slope is just the difference in y over the difference in x. So if you are to convert it to, let's say, percentage, meaning that you have to, after that, multiply it by 100%, then you get it in percentage. But now you're just finding the slope. So you take at point C. Where is point C? This is point C. Then this is point H. So point C and point H. So look at the use levels. The use level are those changes. So you have 97.4.51 and 98.00. So it will be the difference between this one and this. Then the distance between those two points. So you have point C and point H. The distance between them here, the change here is 20. And the change at H is 70. So 70 minus 20 will give you 50. That will be for the X. And the Y will be the 80 and 97.5. Then the what? 98.00. So the difference between this one over the difference between this one will give you the slope distance or the slope between these 2 points. Okay. Then at number 6, question 6 said, as shown in table 1, the corrections that should be applied to the observed angle at point D, assuming the same error of for each angle will be. So table 6, table 1. So this is table 1. So now these ones are for tutorial observations. So what you do is that, okay, let me try and use the question in the handout to answer this question. So let me go to this place. So let me use this one. Okay, so it's something like this. So now these are the angles given to us. So the same applies to the one in the question. These are the angles, horizontal angles given to you. So what to do, you have to know the sides of the polygon. So you have A, B, C, D, E. So you have 5 sides. So from A to B, B to C, C to D, then D to E, then E to A. So you have 5 sides. So now you have to calculate the total internal sum of internal angles by using this formula. So you have the formula here, n minus 2 multiplying 180. So the n is 5. So 5 minus 2 times 180, that will give you 540. So 540 is the total internal angles here, meaning that if you sum all these, you have to get a 540. So if you don't get that 540, meaning that the assumption wrong, so you have to adjust the angles. So now that's what we have been told to find. So we have to find the individual corrections will be attached to it. So when you look at the one here, you can see that we are having the angles here. So here to the side was 5. You have A, B, C, D, E. So the size was 5, A, B, C, D to E. So now after summing the angles here, we got 553 degrees, then 59 minutes, then 0 seconds. So we know that it's not up to 540 we're supposed to get. So what we do is that we have to find the error. So always the error is the difference between the observed minus the computed. So the observed is always the one you calculate on the table. So this is our observed value. And the computed is the one you use the formula to compute. that is the 540 you will get. So it will be this one minus the 540, and that one will give you I give you 60 seconds to give you 60 seconds. So 60 seconds here. So if you add the 60 seconds, we know that 60 seconds make us 1 minute. So that 1 minute will be added to the 59. And we know that 60 minutes also give us 1 hour or 1 degree. So meaning that here will be 540, meaning that it will balance. So meaning that the difference between the observed and the computed is 60 seconds. So now, meaning that we have to uh, add those various individual corrections to it. So what we do is I have to divide the error into the various sides. So 60 divided by 5 will be 12. So meaning that in each line we have an error of what, 12 seconds. So in the same way you will apply to this one. So since this one they are requiring for what, corrections, so it will be 539 59 minutes then 0. So the difference will be minus. So if the error is minus, then the if the error is minus, then the correction will be plus. So meaning that the corrections here will be plus. If you add them and it is less than the angle we're supposed to get, meaning that the corrections here will be plus. If it is more than, meaning that the corrections here will be minus. Okay, so you add it to, you get the adjusted angles. So after getting the adjusted angle, when you add them, it should be sum up to the 540 we're expecting. Okay, so that's for question 6. Now question 7. This one is the EDM, and the EDM you have to use the formula that as they give us some parameters here. They give us frequency, they give us lambda, they give us the time. So what you have to do is that you have to use the formula. I have to use so by solving this, you can use the formula V as the velocity equals to frequency times lambda. But this one, the parameters given, there wasn't any velocity inside, so I have to get something to substitute inside. So now let's check something. We're asked to find the distance, that distance AB. So meaning that our interest is the distance. So I have to get a formula that will link us to get a distance so that I can substitute. So you can just use velocity equals the distance over time, right? So we have time there, and the parentheses to they give us time. So meaning that you can equate the velocity equals to distance over time with the velocity equals to frequency multiplying lambda. Then you make the distance change of subject. So you can make the distance the subject. Then you can just substitute all these ones inside, and you can get your answer. Then let's go to question 8. Said find the quadrant bearing of line DE of the table 3. Okay, using table 3. So we're going to find the quadrant bearing of line DE. So table 3, line DE. So you can see we have the bearing here given to us as 92. So 92 meaning that it's past the first quadrant. So you have not. Let me try and see if we can use the diagram I drew first. So let me bring in okay. So now it's past this quadrant. So now 92 is this place, this quadrant. So we know that it falls within this quadrant. So what you can do is that you want to find the angle here. Want to find the angle here, so you always have to subtract it from, or always have to read from the main cardinal point. So the main cardinal at this quadrant here is the south, so it should be southeast at this quadrant. Now, since it's more than this quadrant, meaning that if you subtract 90, so let me see this angle. So that the angle here is 92.67. So if I subtract 90 from 92.67, I'll get 2.67. So now 2.67 will be the angle left here. But now I have to read from what, south to west. So meaning that the angle here too is 90. You can just subtract 2.67 from 90, and I'll get 87 point, I think 3 or something. So that will be the quadrantal angle. I'm not having it calculated, that's why. So you can do that by using that principle. You can just subtract 90 from the 92.67, and you get that small angle here. Then you can just subtract that small angle from 90, you get the angle from this place to the line. So the line will be somewhere here. That from here to here is 92. Okay. So that's how you go about it with the quadrantal bearing. And with the partial coordinate of A. So for partial coordinates, you'll be using the formula. Let me open the PDF so that I can just use that one to make an example. So these are the partial coordinate, the formula for partial coordinate. So for latitude, we get L cos the bearing, and for the departure, we get L sine the bearing. Okay. So now what you have to do is that you have to find the partial coordinate of point A. So this point A at table 3. This table 3. So these are the coordinate for point A. And for the partial coordinate, what we need, the parameters we need is the distance and the bearing. The distance and the bearing. And since we know the point of what, or the coordinate of what, eastings and also of point A, we can find the bearing of point A and also find the distance of point A. So you can use tan inverse of change in eastings over change in northings to find the bearing of point A. So you can use, so the bearing will be A to B. That will be the line direction from A to B. So you can use that one to find the bearing, and the distance of from A to B, you can use the coordinate here. So that one to square root of change in distance all squared and plus change in northings all squared will help you to get the distance. You can just substitute it inside the formula here to find the partial coordinate for the latitude and the partial coordinate for the departure. I think this will be very helpful for you. If you don't understand it, you can just hit me up. Then we can vibe. Thank you very much for your attention.